Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. ABCD is a rectangle within a circle of center C and radius 10 as shown in the figure. BC is equal to 8. Diagonal BD when extended out meets the circle at point E. Which of the following is closest to the length of BE? So we have ABCD being a rectangle that's inside a circle, and the center C of the circle is also one of the vertices of the rectangle. One of the first things that we note is if we join A and C, so I have this dotted line AC, which is one of the diagonals of the rectangle. But C being the center of the circle and A being a point on the circumference, AC is also a radius of the circle. So that makes AC is equal to 10. And since AC and BD are diagonals of a rectangle, we know the diagonals of a rectangle are equal to in length to each other. So we basically have BD is equal to AC is equal to 10. So now consider the right angle triangle BCD, where the hypotenuse BD is 10, one of the sides BC is 8, and we have to find what the side DC is. So we can apply Pythagoras Theorem, which states that DC square plus BC square is equal to BD square, and then substitute the known values of BC and BD, and then we can solve for DC, and it's very simple to obtain DC equal to 6. So now we do a construction, and we basically drop a perpendicular parallel to the sides DC and AB, and this perpendicular meets the side BC of the rectangle extended out at point F. So by construction, we have two similar triangles here. The bigger triangle, triangle BFE, and then the smaller triangle, triangle BCD. And we already know what the sides of triangle BCD are. They are 6, 8, and 10. So the sides of triangle BFE will be proportional. And we can write those sides as EF is equal to 6K, BF is equal to 8K, and BE equal to 10K, where K is some constant of proportionality. One thing to note here is that CF will be simply BF minus BC, and BF is 8K by our assumption, and BC is 8, so that makes CF equal to 8K minus 8. Next, we make another construction. We join the points C and E, and CE is one of the radius, because E is a point on the circumference, C is the center, so that makes CE a radius. Now, considering the right angle triangle CFE, we apply Pythagoras Theorem, CF square plus EF square equal to CE square. And like I said, CE being the radius is equal to 10, so that makes the right-hand side of this 10 square. So what is CF? We have obtained CF as 8K minus 8. EF is simply 6K, so we can write 8K minus 8 whole square plus 6K whole square is equal to 100. And now it comes to the matter of solving this quadratic equation. So we can write this as 64K minus 1 whole square, so within parentheses, and then 6K square becomes 36K square is equal to 100. And if we divide both sides of this equation by 4, we get this, and we also expand out K minus 1 whole square, so that's K square minus 2K plus 1. So we basically get 16 multiplied by within parentheses K square minus 2K plus 1 plus 9K square is equal to 25. And then we can form the quadratic equation, the classic ax squared plus bx plus c, and this is what it comes to. 25k squared minus 32k minus 9 is equal to 0. And we can solve for the root of this quadratic equation by simply applying the formula. And if we do that, k comes to 32 plus minus within square root 32 squared plus 4 multiplied by 25 multiplied by 9. And then in the denominator, we have 2 times 25. From here on, we will basically do some approximation, especially for the term within the square root. So what I do is I take 4 common from the terms within the square root, and then I'm left with 4 multiplied by 16 squared plus 25 multiplied by 9 within parentheses. The whole thing is still under square root. And if I calculate the term within the square root, I have basically 32 plus minus 4 multiplied by 481. So 16 squared is 256, 25 multiplied by 9 is 225. So we add those up, we get 481. So it's 4 multiplied by 481. Now this is still a messy square root, and in order to avoid calculation of this square root, I do an approximation here. I think about what's a perfect square around 481. We know that 4 is already a perfect square, but if I can find the closest perfect square to 481, that would basically help me arrive at an approximation. We know that 20 square is 400, right? So 21 square is 441, and then 22 square is 484, which is closest to 481. So we can write this approximately as 32 plus minus within square root 4 multiplied by 484. And in the denominator, we still got 50. So now we have basically in the approximation a perfect square within the square root term. So we can express that as an integer. And this is what comes to 32 plus minus 44 divided by 50. Of course, here we ignore the negative root, so we just take the positive root, and k approximately comes to 76 divided by 50. And then we know that the length BE that we are asked to find out, that's simply 10 times k, right? So we can basically write BE is equal to 10k, and k is 76 by 50, so 10 gets cancelled out, and we are left with 76 by 5. And when you approximate 76 by 5, 15 is a good approximation, because 75 by 5 is equal to 15. So that's how we approximate BE, and then going through all the options that are listed, the closest one is option D, 15. So the correct choice will be option D, 15.